March 11th, 2011. A wall of water 40 meters high erases entire cities from the map. 18,500 people lose their lives in minutes. Japan's response? Build the most ambitious coastal defense system ever constructed by mankind. It's a 400-kilometer concrete fortress rising from the Pacific Ocean. But can you actually wall off the sea? Japan sits on one of the most dangerous intersections on Earth, where four tectonic plates collide like grinding gears in a planetary engine. The Pacific Plate, Philippine Sea Plate, Eurasian Plate, and North American Plate create what scientists call the Ring of Fire. The numbers are staggering. Japan experiences over 1,500 earthquakes annually. That's 4 tremors every single day. 126 million people live on just 377,000 square kilometers. Imagine cramming the entire population of Mexico into an area smaller than California. When the magnitude 9.1 Tohoku earthquake struck in 2011, it unleashed energy equivalent to 600 million Hiroshima bombs. The tsunami that followed traveled at 800 kilometers per hour, faster than a commercial jet. Waves reached heights of 40 meters, tall enough to submerge a 13-story building. The damage? $400 billion, the costliest natural disaster in human history. In the coastal town of Rikuzentakata, the wave consumed 80% of the city in less than 30 minutes. After this catastrophe, Japan made a decision, never again. But how do you defend against the ocean itself? The planning began immediately. Japan's Ministry of Land, Infrastructure, Transport and Tourism assembled 2,000 engineers, geologists, and oceanographers, a scientific army tasked with the impossible. Using LiDAR scanning technology that fires 150,000 laser pulses per second, they mapped every centimeter of 400 kilometers of coastline. Supercomputers modeled 10,000 tsunami scenarios with the precision of a chess grandmaster thinking 50 moves ahead. The challenge seemed insurmountable. Japan's coastline isn't a smooth line. It's a chaotic tapestry of steep cliffs, fishing harbors, river mouths, and urban centers. Engineers identified 193 critical segments, each requiring custom solutions. Local communities voiced deep concerns. Would these concrete giants destroy their ancient connection to the sea? One elderly resident of Kazunuma put it simply, "The sea gives us life. Will this wall give us death instead?" The final plan emerged, a barrier averaging 12.5 meters in height, equivalent to a 4-story building stretching for 395 kilometers. To put that in perspective, if you place the Great Wall of China and the Berlin Wall end to end, Japan's Tsunami Wall would still be longer. Budget, $12.7 billion. But the real challenge was still ahead, turning blueprints into reality. This isn't just a wall, it's an engineering marvel that would make the pharaohs weep. The project demanded 8.5 million cubic meters of reinforced concrete, enough to build 35 Empire State Buildings. Picture this. If you loaded all that concrete into standard trucks, the convoy would stretch from Japan to Australia. The steel reinforcement alone totaled 1.2 million tons, heavier than 10,000 blue whales arranged in triple-layer grids like a three-dimensional spider web. How do you even begin to build something this massive? The equipment reads like science fiction: 340 custom-built concrete pumps, GPS-guided pile drivers with 5-centimeter precision, and telescopic cranes reaching 65 meters, tall enough to look down on the Statue of Liberty. The concrete formula itself represents a revolution in materials science. Engineers created a mixture so advanced it fights back against time itself, designed to last over 100 years, with corrosion inhibitors and water-resistant additives that would make a duck jealous. Then came the moment of truth: construction. Building began simultaneously at 47 sites along the coast, like an orchestra with 47 different sections, all playing the same symphony. Workers excavated trenches 8 to 12 meters deep in areas with soft soil, the kind that turns to jelly during earthquakes. They drove 600 steel piles per kilometer into bedrock, some reaching 45 meters down. That's deeper than most shipwrecks lie. Giant slipform systems moved continuously upward like slow-motion elevators, pouring concrete in 3-meter increments. Each 50-meter wall segment took 14 days to complete. Day and night, the work continued, rain or shine, earthquake or typhoon, but nature doesn't make anything easy. At the Rikuzentakata section, where the tsunami had literally erased a city, engineers did something unprecedented. They built on the tsunami debris itself, compacting the ruins of homes and schools into a stable foundation. From death, they created life. At Tsunami Harbor, the wall performs an elegant 90-degree curve to protect the fishing port. Imagine trying to bend a four-story building around a corner. In Minami Sanriku, engineers inserted transparent acrylic panels every 100 meters. These Hope windows, each strong enough to stop a truck, preserve ocean views for grieving residents. At 89 river mouths, automated floodgates were installed, mechanical guardians that never sleep. Each gate weighs 450 tons, heavier than 3 Boeing 747s. They close in 7 minutes when sensors detect seismic activity and cost $15 million per unit. The human cost was staggering. An army of 18,000 construction workers rotated in 12-hour shifts. During peak construction in 2016, 85 simultaneous work sites operated around the clock. Winter temperatures plunged to minus 10 degrees Celsius. In 2015, Typhoon Goni halted construction for 23 days. One construction foreman, Hiroshi Tanaka, later recalled, "We weren't just building a wall, we were building a promise that our children wouldn't drown like our neighbors' children did." But could it actually work? When a tsunami approaches at 500 kilometers per hour in deep water, it moves faster than a bullet train. Near shore, it slows to 50 kilometers per hour. But here's nature's cruel trick. The wave height increases exponentially like a giant standing up. How do you stop something that powerful? The wall works through pure physics and brutal engineering. When the wave hits, imagine a heavyweight boxer punching a mountain. Steel-reinforced concrete withstands 45 megapascals of pressure. That's 4,500 tons pressing on every square meter, equivalent to parking 900 elephants on a dinner table. 40% of wave energy reflects back to sea, creating interference patterns that reduce subsequent waves. The remaining 60% dissipates through concrete compression and turbulence, transforming deadly motion into harmless heat. But engineers didn't stop there. They created something unprecedented, a thinking wall. The system includes 2,800 sensors embedded throughout the concrete like a nervous system. Accelerometers detect vibrations with sensitivity that can feel a cat walking across the structure. Strain gauges monitor stress levels. Tilt meters measure tilting with a tolerance of just 0.5 degrees, less lean than the Tower of Pisa. Data transmits to 12 regional control centers every 30 seconds. AI algorithms predict maintenance needs 5 years in advance. Japan's earthquake early warning system connects directly to the floodgates. When seismic sensors detect P waves 6 to 8 seconds before destructive S waves, gates automatically close. Response time, 4.5 minutes, faster than any human could achieve. Yet one question haunted engineers. How do you test a tsunami wall without a tsunami? Engineers built a 1 to 50 scale model at the Port and Airport Research Institute, creating 2-meter waves equivalent to 100 meters at full scale. Cameras capturing 10,000 frames per second revealed the ballet of destruction in slow motion. On-site, ultrasonic testing detects internal voids invisible to the naked eye. Drones with AI cameras identify cracks thinner than 3 human hairs. Then nature provided an unexpected test. In 2016, a magnitude 7.4 earthquake struck near Fukushima. The wall trembled but held. Analysis revealed hairline cracks in 23 sections. Engineers immediately added 340 tons of reinforcement and modified the concrete mix to increase strength by 18%. The wall learned, adapted, evolved. Annual maintenance costs $85 million, the price of vigilance. But was the price worth paying? The wall now shields 470,000 residents in 89 coastal communities. Computer models show it would have saved 11,000 lives in 2011. That's 11,000 fathers who would have watched daughters marry, 11,000 futures that wouldn't have ended in cold Pacific water. The fishing industry experienced resurrection. Tsunami saw revenue explode by 340%. Coastal property values rose 28%. Rice production recovered to 95% of pre-tsunami levels. Yet not everyone celebrates this concrete triumph. Critics argue the visual barrier creates a psychological prison. Studies show 30% reduction in coastal bird populations. Seagrass beds declined 40% in some walled areas. Some seismologists warn the walls might encourage risky coastal development, a false sense of security. And the cost, $12.7 billion, makes critics wonder if elevated housing might have been wiser. 74-year-old fisherman Takeshi Yamada says with tears in his eyes, "I understand the necessity, but when I wake up and see concrete instead of sunrise over water, something died in our town. My grandfather taught me to read the waves. What will I teach my grandson how to read concrete?" But Mayor Futoshi Toba of Rikuzentakata, who lost his wife to the tsunami, counters with steel in his voice. "Every person who lost family in 2011 says the same thing. Build it higher. I'd rather see concrete than coffins." The world watches and learns. 15 countries have sent delegations like pilgrims seeking wisdom. Indonesia plans a 200-kilometer barrier for Java's northern coast. The Philippines adapts the design for Manila Bay. The United States considers similar systems for the Pacific Northwest. Japan's wall has become a blueprint for coastal defense in an era of rising seas and angry oceans. As climate change intensifies storms, will concrete fortresses line every coast? Will our children inherit a world where beaches are memories and horizons are vertical? 400 kilometers of concrete. $12.7 billion, a fortress against nature itself. Japan's Great Tsunami Wall represents humanity's eternal question. Can we engineer our way to safety, or are we just delaying the inevitable? Is this wall a shield or a cage?